Hello everybody, and thank you for checking in on this video. This video is set up to discuss the main topics that will be addressed in Friday's final test. You will notice that I'm going to do my best to go and explain the questions as well as discuss the answers and the rationale behind the answers. Alright, so getting right into this, some of the questions have to do with the techniques used for measuring. Some of these techniques are going to be discussed. The first one right there, looking at number one. Very simple question, but it's a question talking about a couple of items. One of the items being whether or not you understand the vocabulary of a word that's defined as the curvature of the water. So we're talking about the curvature. We're talking about this curve right here at the very bottom that you can see right in this area right there. And we just want to make sure that people know these terms. But your options include volume, gram, mass, meniscus, and balance. Really kind of easy. We're asking for a curvature, and so this word right here, this line, if you will, is something that we do find in our knees. We find them in graduated cylinders. This image, this curvature, we call the meniscus. And so the meniscus is the best answer for this question. Alright, scrolling on down here. Question number 2. When measuring the volume of a liquid in a graduated cylinder, where do you take your reading from? Select the correct letter from the picture above. And so if we look at the options we have here, we do indeed get to see a couple different letters to choose from. We have A, B, and C. C is pointing to the bottom, B in the middle, A to the top. In this case here, one of the consistencies, and a lot of it has to do with how narrow the graduated cylinder is. The more narrow it is, the higher the meniscus will be running up the side. So if it's a really narrow tube, the meniscus will curl up more and more. So in that case, it's kind of misleading to use the edge or the top of the meniscus. So they always recommend that you use the bottom. So in this case here, C makes the most sense. Alright, moving along here. Number 3. Please select the correct answer to which the words match up to what they measure. We have volume, length, and mass. Of these three, we can go and associate 3 metric units. The best unit here to go with these terms, let's see, volume, well, I know that volume is measured in liters. So let me go and try that again. Volume is measured in, excuse me, in liters. And, oh boy, that's no good. And then length is measured in meters. So length is in meters. So I'm going to change this up to 24 here. Meter. And that's better. And then mass, well, when we're measuring our mass, we measure in our grams. So if the order is liters, meter, gram, we should go and have we should go and be able to figure out what's the correct order here. Well, hopefully you're noticing it. Liter, meter, gram is D. Sweet, there's our answer. Alright, next up. Oh, and on a side note, why is it so easy for these terms to go and be converted from one to the next? A lot of it has to do with the fact that the metric system is based upon the powers of 10. So you can move and convert in between the units as such. Alright, so number 4. This preferred system of measurement in science is based upon the powers of 10 and is predominantly used throughout the rest of the world. Just kind of mentioned it, and it is rather unfortunate that is this case, but the metric system is what the rest of the world uses. We here in the United States, we use the imperial system, so that's anything having to do with pounds, inches, and so on and so forth. But in the rest of the world, they would use things like the grams, the meters, the liters, all those. So the rest of the world's kind of got to figure it out. They like to use the system. It's simple, it's straightforward, but the US and a couple other countries still like to use their own thing. Alright, getting on over here to number 5. If you know the mass and volume of a substance or object, you can solve how packed the matter in the object is. The formula is mass divided by volume. This is called blank. This is just a vocabulary approach to this question, but for those of you that remember and studied and looked at your interview questions, the best answer here is density. Reason being, well, it's the only one here that has an actual formula associated with it. All the other ones, these are just units, or what you would actually measure, and this is just an observation that doesn't make any sense. So density is the best answer here. Plus density is how packed the matter in an object is. Alright, the quality of being correct is the definition for which word. Got two main words you can use. There's precision and then there's accuracy. You'll remember that accuracy is being correct and precision is being exact. So best answer here is going to be accuracy. So accuracy is our best answer here. You'll remember that density is its own definition. That's m divided by v, and observation, that's just using your senses to collect information. Alright, let's go to another question here. If we had a two-dimensional object and we're asked to solve for the area in that 2D object, this is area, we would use what formula? Well, it's important to remember that there's the density formula, there's the area formula, and then there's the volume formula. Density. You guys remember the formula for density? Good job. Mass divided by volume. Area, length times width. Excellent job. And volume, that's a 3D. Length times width times height. So our best answer is going to be, you got it, B. Length times width. Nice job. Alright, let's cruise on down to another part of the quiz here. Excuse me. Number 8. Alright, using the ruler, please measure the length of the bolt in centimeters. It's really kind of nice and easy to do this with the computer program, but let's see if I can go and set this up for you. I've got the edge of the bolt right here, so I'm going to bring this line straight down. And I got the other edge of the bolt right here, so I'm going to bring that one straight down. Alright, so you're just doing some little bit of measurements here, and we notice we're working in centimeters, so this is actually the right unit. It says millimeters here, but that is referring to each one of these lines as a millimeter. The big ones are centimeters, and the middle length ones are half centimeters. So you've got what are you guys thinking is your best answer here? I would accept a couple answers here. Curious to see what you would think. Between these two, 7.5 and 6.5, which one makes the most sense? Anybody? None of these. You got it. The correct answer is actually 5.5. It has to do with the fact that, yes, even though it's coming right here and I can see the 6, hopefully all of you are noticing, I did not start at the 0. I started at the 1, which means I need to subtract 1. So 6.5 minus 1, 5.5. There you go. Excellent job. Last but not least, we have another question here, number 9. If you notice on this question here, it's asking you to tell us what is the mass of an object in grams. And so if we look in a little bit closer on this picture here, we zoom in, we get a chance to see the sliders, the riders on the triple beam balance a little bit better. So if we were to kind of take a little glance and figure out what these numbers are, go and get a size that's appropriate here. That'll work. Alright, let's start with the hundreds. What do we have? You got it. 300. How about the tens? Nice. Excellent. 70. And how about the ones? Well, is it 3 or is it 4? Definitely 3. However, the point is right here. And that point is kind of, I don't know, if I counted this, I'd see 0.1, 0.2, 0.3, 0.4, kind of right in the middle. So, if we add them all up, 373.3 to 373.4, well, somewhere in the middle of those two, halfway between 30 cents and 40 cents would be, you got it, 35 cents. 373.35 is indeed the correct answer. Alright, good job. Let's look at our last couple of questions here. I'm going to zoom out a little bit. Alrighty. So, this question here is asking you to do a little bit of finding the volume of an irregularly shaped object. So, being irregularly shaped object, we have to use water displacement. So we've got to go and kind of figure out what is the displacement of this water. We can go and do this nice and easy. Let's go and find our initial volume. You'll notice I need to, oops, bring that back. I need to go and bring that line up a little bit here. The line is just ever so slightly off. There we go. So, and if you're trying to move through this question, I'm hoping that you're seeing that the actual graduated cylinder here is not set up so that every line is equal to 0.1. Instead, if each line is equal to 0.2. So if this is 4 and this is 5 and it's less than 5, bottom of the meniscus, we got 4.2, 4.4, 4.6, 4.8. So if that's the case, I'm going to put 4.8 over here for volume initial. And we throw the dinosaur in, and now we see that the level has gone up and increased. So we need to draw a new line to where we are. Alright. Well, it's above 5 and it's below 6. Let's count them out. 5.2, 5.4, 5.6. So, final volume, 5.6. Now, you'll remember that the total volume is equal to final volume minus initial volume. So 5.6 minus 4.8 is equal to 0.8. There's your answer. Alright, let's cruise on down to the last couple of questions here. Number 11. Number 11. Says here, in the pictures below, you will witness 3 conditions. These properties of water were viewed during our lab. Please match up the property with the image that it demonstrates. So put the properties in the correct order as seen below. In example, CAB is the correct order to match up with pictures 1, 2, 3, CAB. Now, is that right or is it wrong? I don't know. We need to actually kind of look at it. So, we look in these pictures here, and the first one here, we've got some wax paper. So this wax paper has the water beating up on it. Now the water and the wax paper do not get along. So the wax paper is hydrophobic, if you will. That being the case, we want to make sure that the wax paper, what we're witnessing here is that the wax paper and the water, because they're not connecting or attracted to each other, it leaves the water the opportunity to be attracted to itself, which it naturally is. And so the water kind of holds itself in these nice little beads. So if it's attracted to itself, a like material, we're going to say that that is C, cohesion. Moving on over here, we've got some dew droplets, it appears, to have attached themselves through an attraction to a spider web. So we've got unlike material, and the unlike material being attracted, that's A. You got it. And let's go on over here to number 3. Well, we could do process of elimination, but we also can see we've got a liquid, and this would just be, I'll just say it's water, and I'm pretty sure that this is wood or paper, and so these are unlike as well, and it's a special condition where there's an attraction between the unlike materials, but we also get to see that the water is moving up into this material along a surface. The water's moving. That's gonna be capillary action, which is B. Alright, good job. Better make sure that I adjust this example over here. Alrighty. Last few questions. Looks like 3 or 4 actually. Alright. Make some conversions using the supplied chart. I give you a very simple conversion of 1 meter equals to 100 centimeters, 1 kilometer is equal to 1,000 meters, and 1 liter is equal to 1,000 milliliters. So you got 3.7 kilometers here. If it's 3.7 kilometers, and you know each kilometer is equal to 1,000, well, 2 kilometers, 2 km, would be equal to 2,000 meters. How about 3 kilometers? 3,000 meters. Nice. So if I've got 3.7, that would be 3,700 meters. Sweet. We look over here, 2.3 meters into centimeters. Well, I know every meter is equal to 100 centimeters. So if I've got 2 meters, that's equal to 200. And if I have 3 meters, that's going to be equal to 300. And by the way, these are centimeters. So 2.3 meters Well,